All right. Now that you've had an introduction to statistics, definition, and then talking about sampling techniques and misuses of statistics, we are going to take some data and start organizing it. We're going to use tables called frequency distributions, and we're also going to use various statistical graphs. So I'll go through and talk about each one and give you an example. First is frequency distribution. Very handy way to organize data from an experiment. Each piece of data that you collect from an experiment is a data point, and you organize the data on the left side in a column, and then on the right side you indicate the frequency at which those data points occurred. So you don't have to, if like the number 10 pops up 8 times, you don't have to write down 10 8 times. You can just write down 10 and then put frequency 8. So it kind of helps consolidate the data down into a nice table. Now when you do the table, the observed values on the left are put into classes. Each class should be the same width. So I'll explain what that means as I go. But each class should be the same width, classes should not overlap, and each piece of data should belong to a single class. All right, so what does all that mean? Well, here's an example of a frequency distribution. The data given is listed there, various integers from 40 up to 97, not including all of them, but some repeat, some don't. And below that data list is a frequency distribution. Notice on the left side you have your class column, and in this case the classes are 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. So the class from 40 to 49 should cover all the data points from 40 to 49 inclusive. Then the class from 50 to 59 includes all data points that fall within that range, including 50 and 59, and so on. So then we go back for the frequency and we say, well, how many data points fall from 40 to 49? We have 1, 2, 3, 4, 5, 6, 7. So it stops with 7. So the frequency is 7. So this particular table doesn't give you information on the specific data points, but at least you know the range and how many numbers fall within that range. 50 to 59, you got 1, 2, 3, 4, 5. So the frequency is 5. 60 to 69, you got 1, 2, 3, and that's it. It includes, like, you can include 60 and 69 in there. So it's 3. 70 to 79 is 1, 2. 80 to 89 is 1, 2, 3, 4, 5, 6, 7. And then 90 to 99 is just this one right here. So there's a frequency distribution. Now notice that the classes, like 40, if this one goes from 40 to 49, the next one picks right up at 50. There's no gap, no overlap. And it's like that for all the successive classes up, for as low as you need and for as high as you need. You don't need to go below 40 to 49 because your data starts with 40. You don't need to go above 90 to 99 because your data stops at 97. But the classes still are all the same size. 40 to 49 includes what, 10 integers? 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. 50 to 59 includes 10 integers. 60 to 69, 70 to 79, 80 to 89, 90 to 99. Each one includes 10 integers. Then notice that every time you have one class ends, the next class picks up right after that. No gaps, no overlaps. So that previous slide, they said each class should be the same width. So that was each class is the same size. The classes should not overlap, and each piece of data should belong to a single class. So each of these pieces of data was only included in one class somewhere along here. Like 40 didn't get included in more, and it got included in the class 40 to 49, but in no other classes. So you can't have your classes set up so that data could go into more than one of them. Here's a couple other rules or terms. The lower class limit is the lowest possible number in a class. Upper class limit is the highest possible number in a class. Class width is the difference between the lower class limits of two successive classes or the difference between the upper class limits of two successive classes. Modal class is the class with the highest frequency, and midpoint of a class is the class also called the class mark, found by computing upper limit plus lower limit divided by 2. Okay, so let me go back to what we were just working on. Like for the first class, the lower class limit is 40. Upper class limit equals 49. The class mark, or midpoint, you take the lower class limit plus the upper class limit and divide by 2. So you got 89 divided by 2, which is 44.5. I wish it would quit doing those lines, those god-awful lines. Let me erase them and I'll rewrite the stuff that disappears. So we had 40 plus 49 divided by 2 was 89 divided by 2, which was 44.5. So if you were on a number line and looked at the number line from 40 to 49, 44.5 would fall smack dab in between, in the middle of 40 to 49 on the number line. So that's, you know, your lower class limits. That column shows you your lower class limits. And then that column shows you your upper class limits. If you want to find class width, you could take any two classes that are successive, you know, side by side. You could take either their lower class limits and subtract those, see what the class width is, or you can take upper class limits of two successive classes and subtract those. And it'll give you the same number either way. You know, whatever you pick, whatever two lower class limits you pick, successive lower class limits, or whatever two successive upper class limits you pick, when you subtract, you're always going to get 10. 10 is the class width. If you count from 40 to 49 and just include the integers, you get 10. What else did we talk about? We talked about, oh, not that slide. Talked about lower class limit, upper class limit, class width, midpoint, and modal class. We didn't do that yet. Modal class is the class with the highest frequency. So in this case, we've got two of them because the highest frequency is 7, and we've actually got two classes with a frequency of 7. So in this case, we have modal classes. You can have more than one mode, but the mode is the number that appears the most often. Or in this case, modal class is the class that appears the most often, has the highest frequency. So modal classes, you got 40 to 49 and 80 to 89. And that's it. Just whatever that highest frequency is, the class or classes that has that would be your modal class or classes. Nothing else. Okay, so I think we covered all of those definitions there. All right, let's make one of our own frequency distributions. This is a set of data from a hot dog vendor who recorded his sales in hot dogs for 32 consecutive days. And then he listed the numbers of hot dogs in numerical order. But you do have 32 pieces of data here. And it says construct a frequency distribution letting each class have a width of 1. Okay, so we go to construct this frequency distribution. Our hot dog vendor has his number of hot dogs sold That's the data points. Each number of hot dogs sold daily. The other side is the frequency. How often this particular sales number occurred. And with a class width of 1, you're only going to be listing one number at a time. The lowest is 15. Class width of 1, you just write 15, and then you go right to the next integer, 16, because then you can subtract these two and you get 1. 17 is not a data point, but you go ahead and list it. Like, you want to go in order. You don't want any gaps. You don't want any overlaps between your classes. So 15, 16, 17, 18, all the way up to 29. This is a long one. I'm going to run out of room. So let me do it over here too. All right, so how often does 15 occur in the data? Well, it looks like there were 3 different days where he sold 15 hot dogs that day. So the frequency is 3. So here, the frequency isn't telling us how many hot dogs, but rather how many days did he sell that many hot dogs in one day. 16, you got 2 days where he sold 16 hot dogs each day. 17, there's 0 days where he sold 17 hot dogs. 18, there's 3 days. 19, there's 4. 20, there's 3. 21 is 5. 22 is 2. 23 is 2. 24 is 1. 25 is 2. 26 is 1, and then I ran out of space, so I came over here. 27 is 2. 28 is 1. 29 is 1. So it's still number of hot dogs here, and then frequency there. Normally you would just make sure to make it one long table, but I ran out of space. So. But there you go. That's an example of a frequency distribution with a class width of 1. Now notice that your frequencies, if you add them up, should add up to how many data points you have. 3 plus 2 is 5, 5, 8, 12, 15, 20, 22, 24, 25, 27, 28, 30, 31, 32. And that makes sense that we have information for 32 consecutive days. We have 32 data points here, so the frequency should add up to 32. And that's going to be the case each time. Your frequency should add up to however many data pieces you're looking at in your list. All right, so for this one, each class just has one integer in it. You have your frequencies. What's the modal class? You're not going to be worrying about upper class limits and lower class limits here with just class width of 1. You're also not going to worry about class mark or midpoint because it's just one number. But modal class still is the class with the highest frequency. So it looks like it's 21. So sales of 21 hot dogs occur the most often in that within that 32 consecutive days. So yeah, we're not going to worry about the things I just said, the limits or the midpoint. There's one. What else? We talked about modal class and class width. We already have class width as 1. So all right. Let's do one more. Here we have a table of the ages of 44 presidents at inauguration as of 2015. Grover Cleveland was elected both as the 22nd and 24th president. They went ahead and listed his ages at both of those inaugurations here. Okay, and it says construct a frequency distribution with the first class of 42 to 47. So the problem tells us what to start with for our first class. Okay, so the ages are going to be the left column, and then the frequency that those ages occurred is going to be the right column. And this one's going to be a little more fun because the data is not in numerical order for us. All right, now they told us the first class had to be 42 to 47. Oh my gosh. Now remember, classes can't overlap or have gaps. So if this one ends with 47, the next one needs to start with 48. So it was doing fine, and then suddenly it starts doing this. I don't know the rhyme or reason. Anyways, so if we want to figure out how far to go in that second class, we've got, ay. Can't even breathe on this thing. It's making everything jump around. We've got lower class limits that we can use to figure out what the class width is supposed to be. Because we can subtract 48 and 42, and we see that the class width has to be 6. I might have to pause and just like check this thing out the window for a minute before doing this anymore. So if you want to get the upper class limits of this next class, just add that class width to the previous upper class limits. 47 plus 6 is going to give you 53. Next one has to start with 54, which is not only consecutive from 53 to 54, but also 54 minus 48 is 6. And then 53 plus 6 is going to give us 59. Next one has to start with 60. 59 plus 6 is 65. Next one has to start with 66. 65 plus 6 is 71. Do we need to go any higher than that? What is our highest age? I'm seeing 69 as the highest age there. Kind of quickly scanning all the numbers. Yeah, it looks like 69 is the highest age. So the class was 66 to 71 is sufficient. We can stop there. Now remember, these are the ages of the presidents at their inauguration, not necessarily how old they were when they finished their office. All right, so for the first class of 42 to 47, let's count up how many of the data points fall within that class. Okay, in the first row we have 1. Then we have 2, 3, 4, 5, 6. Remember, the class of 42 to 47 includes 42 and 47. So there's 6 presidents that had ages that fell from 42 to 47 at inauguration. 48 to 53. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. So frequency of 11 there. 54 to 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 of them. 60 to 65. 1, 2, 3, 4, 5, 6, 7, 8. So 8 of those. And then 66 to 71. 1, 2. So there's only what, 2 of those. So you add up the frequencies. 6 and 11 is 17, plus 16 is 33, 8 is 41, and 2 makes 43. I missed one somewhere. Oh, man. All right, let's go backwards. 66 to 71. I've got 1, 2, okay, I've just got 2 there. 60 to 65. 1, 2, 3, 4, 5, 6, 7, 8. Got 8 there. All right, 54 to 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's what it was. 54 to 59 actually has 17. So I can erase that 6 and put a 7 in there instead. Okay, so now it adds up. 17, 34, 42, 44. Double check. 48 to 53, is that actually 11? Or 42 to 47, is that actually 6? 1, because I'm recording, you can't correct me right now. 2, 3, 4, 5, 6. I'm only seeing 6. All right, so I think we're okay. So there you go. There's your frequency distribution for the ages of 44 presidents at inauguration. They told us the first class was the 42, 48, 54, 60, and 66 were all lower class limits. The 47, 53, 59, 65, 71 are all upper class limits. You already know what the... That really went far. I don't know why. You already know what the first class had to be. You know what the class width is because we had to find that when we were trying to figure out upper class limits on that second class and moving forward from there. So you know the class width is 6, but you can take any 2 consecutive upper class limits or any 2 consecutive lower class limits and subtract and you'll get 6. Let's see, how about the class mark of the 4th class? Let's see what that's going to be. So the 4th class is 60 to 65. So you add 60 and 65 together and then divide by 2. So you have 125 over 2, which gives you 62.5. So that's the class mark of the 4th class. You can do that for any of the classes. Just add up the upper and lower class limits and divide by 2 for a class. Class mark or midpoint of a class. And then as far as the modal class, in this case, it's the 54 to 59. Has the highest frequency. I just breathe wrong and it does this. So that's right here, highest frequency was 17. So most commonly presidents are in the age range of 54 to 59, which I find interesting because You just have to be at least 35 to run for president. So I find it interesting that most of them are already that old when they run. There's been a few that were younger, but already kind of up there. Anyhow, any other things we can pull from this? So we talked about class mark, modal class, class limits, class width. Yeah, okay, so there you go. Moving on. As you've seen flashing before you every time this thing goes haywire, we're next going to talk about different kinds of graphs, starting with circle graphs. I'm sure you guys are all familiar with circle graphs, but I want to make sure I go over the math behind it so that you know what you're doing. In a circle graph, 100% of your data is represented in a circle that is divided into segments. The segments take up the same percentage of the circle as the segment data is of all the information. So like if you have certain data that's 25% of the whole, then that segment's going to be 25% of your circle on your circle graph. For example, let's say we have a poll where they looked at online travel websites and how many bookings had been placed within a certain time period. Within this certain time period, Travelocity had 175 bookings, Expedia had 125, Orbitz had 85, and then other websites had 115 combined. And we're interested in making a circle graph to reflect this information on the bookings. Well, one of the first things we have to do is figure out what fraction each website had of the total bookings. Like if with the 175, the 125, the 85, and the 115, those all add up to 500. Travelocity had 175 of those 500. So if you divide 175 by 500, you've got your fraction, but you can also get a decimal. You'll get 0.35. Then move your decimal point 2 places to the right, and you got a percent, 35%. You can do that with each of the websites. Expedia had 125 bookings out of the total 500. When you divide, you get a decimal of 0.25. Move your decimal 2 places to the right, and you get a percent of 25%. Orbitz had 85 bookings out of 500. That's a decimal of 0.17 when you divide. Move your decimal 2 places to the right, and you get 17%. Then finally, all those other websites that they lump together, 115 bookings out of 500. When you divide, you get a decimal of 0.23. Move your decimal 2 places to the right, and you get a percent of 23%. So let's take those numbers and see how to make a graph with them. Well, when you're making a circle graph, you got to figure out, well, how many degrees do I make each piece? Don't forget that there's 360 degrees in a circle. Travelocity had 35% of the bookings, 0.35. Multiply 0.35 times 360, and you'll see how many degrees in the circle will make up 35% of the circle. And you get 126 degrees. And when you're drawing your circle graph, you start with a segment in your circle, and then you use a protractor to help you measure out 126 degrees. Expedia had 25% of the bookings. So 25% of 360 is found by 0.25 times 360, and you get 90 degrees. So Expedia's section is going to be a nice little right angle. Use your protractor. Use this as your starting line, and then use your protractor to measure out 90 degrees. And I actually did that. Hopefully it's pretty close, because trying to do a protractor on a computer screen with this was kind of tough. All right, Orbitz has 17% of the bookings, so 0.17 times 360 gives you 61.2 degrees. And then all the other sites had 23% of the bookings, so 23% of 360 is 0.23 times 360, or 82.8 degrees. If you add up all of those degrees, you will get 360 total. That's one of the things to check with the circle graph, is that all of your pieces, the percent should add up to 100%. All of the degrees should add up to 360 degrees. You add all that up, and you will get 360 degrees. And here's the circle graph all made all pretty. You put a little title up there so people know what you're talking about. So I've said bookings on online travel websites. This particular one's color coded. So purple is Travelocity, and it's labeled with 35%. Expedia is that lovely teal color, 25%. Orbitz is that fuchsia color, 17%. And others that weird orange color, 23%. If I'm doing it by hand, I'll usually just label inside the pie pieces. I'll write Travelocity, Expedia, Orbitz, other. But if you'd rather do a color-coded kind of scheme like this, that's fine too. So there you go. And yeah, all those percents add up to 100%. They must, because it's taking up the entire circle. 35% plus 25% plus 17% plus 23%. Add all that up, and that is 100%. Histograms. Histogram looks a heck of a lot like a bar graph, but in the histogram, your bars are like straight up and down. Your classes are listed at the bottom along the horizontal axis, so each bar represents a class. And then the height, the vertical axis, is the frequency for those classes. So you're pulling your data straight from a frequency distribution. And the heights of the bars tell you the frequencies for each of the classes. Really easy to spot trends and spot your mode and all that because the bars are right there to show you visually what's going on. All right, let's take a look at this example. Let's construct this histogram. We have information about the annual salaries of managers at XCheck Corporation. Our frequency distribution over here shows the salaries in thousands of dollars. So you've got some that make $35,000 to $40,000, some that make $41,000 to $46,000, all the way up to $71,000 to $76,000. So here's our classes for salaries. And over here's our frequencies. How many people make salaries within that range? 3 people make salaries from $35,000 to $40,000. 7 people make salaries from $59,000 to $64,000. So this frequency distribution is telling us our info. So what we're going to do over here is we're going to draw bars to represent each of those classes. So let me fill in the classes here. Hopefully I can squeeze them all in without too much mess. Or what sometimes you do is if you don't want to squeeze the classes in, you can always label it with the class marks. It's another way of doing it. Okay, so 35 to 40 had 3 people. Let's mark this as 1, 2, 3, just by ones, 4, 5, 6, 7, 8, 9. So 35 to 40 had 3 people. So that's going to go all the way up to 3 right there, that bar. 41 to 46 had 6 people. So that bar goes all the way up to 6. 47 to 52 had 9 people, so that's a pretty tall bar. And actually, it's the only one that has 9 people. So right there is your modal class. You can spot it real quickly by that tallest bar sticking up. It's like, oh, there's your modal class because that one has the highest frequency since its bar goes up the highest. '53 to '58 had 8. So although it's high, it's not the highest, so it's not the modal class. 59 to 64 had 7. '65 to 70 had 6. And 71 to 76 had 4. So there you got it. Here's an example of a histogram. Notice too, it's already labeled. I didn't write out all the labels here, but I had them pre-done. It's good to label the title so that people know what this histogram is representing. It's good to label your horizontal axis so that people know what this data is supposed to be from the classes. And it's good to label your vertical axis so that people know what the frequency is really telling you. And there you go. So that's a histogram. A frequency polygon is a lot like a histogram, except instead of bars, you put little dots at the tops, like where the bars would go up to. And then when you're done, you connect dot to dot with straight line segments. Now on the extreme left and extreme right, you make sure to connect those dots down to the ground level so that you close in a polygon. Looks kind of like a mountain range. So going back to this, let me change my color for a second. If you wanted to make a frequency polygon for this one, you would still have a lot of the same labels. You'd have your titles and your axes and all that, but instead of bars, you would draw dots at the tops of where the bars would go, at where the frequencies are to mark. And then you would connect the dots with straight segments because you're drawing a polygon. The polygons are, the sides are made of line segments. So normally I'd say get a ruler out. It's really hard for me to do on the computer screen. But yeah, you connect the dots. And then on the ends, over here, put a dot on the ground and connect down. And then over here, put a dot on the ground and connect down. So the red is a frequency polygon. But notice that now it's a closed-in polygon. So your line segment should be straighter than that. And then stem and leaf displays. I believe this is the last thing. A stem and leaf display organizes the data while still allowing you to see the actual pieces of data. So instead of worrying about classes or other generalizations like frequency, you actually use every single piece of data to make the stem and leaf display. On the left, you have a column for the stems. Those are all the digits to the left of the ones place. So if you have a 2-digit number, you're just going to put 1 digit down there. If you have a 3-digit number, you're putting 2 digits down. Then you draw a vertical line and put the leaves. The leaves are all the ones place digits. And it's kind of cool because if you turned it on its side, it would look a lot like a histogram. Okay, for example, here's your chart of data, and here's a stem and leaf display. When it comes to the number 10, the 1 is a stem of 1, the 0 is a leaf of 0. 15, you've already got a stem of 1 here. You don't repeat stems. Once they're there, they're there. And then the leaf is 5. 24, you have a stem of 2, leaf of 4. 36, you have a stem of 3, leaf of 6. 48, stem of 4, leaf of 8. 45, stem of 4, leaf of 5. So yeah, don't repeat stems, just add more leaves along to this. So like down here, this represents 60, 62, and another 60. So if the same number repeats, you're still going to put it in there. So like notice there's 2 zeros for 2 60s here. The leaves do not have to be in numerical order, but if you want to put them in numerical order, you can. Usually the stems, though, are in numerical order. And if you kind of look at it from the side, the leaves, the length of the leaf list, it kind of makes it look like you have a histogram going on there. Like you can imagine drawing bars around the leaves, and it looks a lot like a histogram on its sides. So you can quickly see from the leaves that the data that appeared the most often had a stem of 4. Like numbers in the 40s appeared the most often. All right, so there you go. So there's some various statistical graphs, as well as frequency distributions. Practice, practice, be able to make all of these graphs, be able to make a frequency distribution, but also be able to read them and get data from them. Know the terminology I covered, because all of that will be on your test somewhere. And I guarantee some of that's on the final exam too. All right, and then when you join us again, we'll talk about measures of central tendency, which are just the good old-fashioned averages that you learn how to do in 4th grade. So we have a couple more sections to go, just some more basic statistical stuff. Thank you for joining us.